Hello, today I'm going to demonstrate how to use InsideDNA platform feature console to cloud. To use this feature, first you will need to log into our application, and if you are not registered, go ahead and sign up. So here I'm signing in with my existing account. And once I'm inside of the platform, I'm going to go to the files, and then in the left-hand side bar, I'm going to choose console. If you log in first time, you will need to activate the console, but if you've done it already, then you will see the console as it is. So first I'm going to show you a couple of the commands to demonstrate that console works just like a normal console. So here I'm just listing all my files. If I want to get a little bit more information about the sizes and what else I have in the directory. And then I'm essentially going to switch to directory called Velvet Assembly, because to demonstrate the way you want to work with the InsideDNA console to cloud feature, I want to demonstrate one of the real life examples. And essentially what I want to do is to basically assemble bacterial genome from the source using Velvet. So here I have 3 different Ralstonia bacterial species genomes downloaded from NCBI database, and I want to use Velvet to make an assembly of one of them with different k-mer sizes. First, to actually be able to submit a task in InsideDNA, you want to know what kind of commands and what kind of tools you actually have in the system installed. To get this information, you need to call alias command, and this one will print a very long list of all the tools available right now, and we can install more tools if you need. Essentially, all the tools, they have this IDNA prefix and IDNA underscore prefix before them. So when you call a command, actually you will have to use this alias instead of the true tool name. Second important, and for example, if you want to search for something, what I typically do, I'm just greping for a command that, I actually interested in. So here I was greping for Velvet, and it has returned 2 main commands for the Velvet. Next thing that you will need to know is actually the task submission script. So it's called IDNA submit.py, and to get all the options of this, you will need to call help, and there are not so many options. In fact, you will have to provide the task name, the number of CPUs, amount of RAM, and then after /e you will have to put the command just the way you would do this, enter this command in the normal Unix machine or on your cluster on the server. What is important, however, is that the tool name should be replaced with the alias, the type of aliases I showed just a few seconds ago, and also you will have to enter the full path to all your datasets. So, for example, I'm going to show you how to do it, but just remember that you need to enter the full path. Then if you would like to get the tool help, basically it's this command. So for example, if I'm interested in InsideDNA Velvet G option, what I can do is I'm going to just put th and then IDNA Velvet. It's going to take a little bit of time, but you will see all the options quite quickly. So now once more I'm going to come back to all the options in InsideDNA submit script. So basically remember that not all the combination of CPU and RAM are possible, so you have to get used to some of the combinations that are actually there. So for example, we have 32 cores for 208 RAM, but not, for example, 3.6 RAM and so on. But you will see it, and the help will tell you if you entered incorrect settings. Few more things that are actually going to be available but not yet available for everyone. Its ability to launch some specific task under the specific project. But for that you will have to know the project name and the project owner email. By now, don't look at this option, it's not yet fully activated. Just use the first 4. So now what I want to do, as I said, I just would like to assemble one of my genomes with the Velvet, and here I'm actually going to copy paste the command from the tutorial itself, because just by hand I don't remember. So what's going on here? Let's have a look. So here what I'm having in the E, I'm actually having first of all the IDNA Velvet Ash, so the alias to the tool, then the name of the output folder, then a kmer size, which I'm going to use for this assembly, 32, the format, type of the data, and then the source data. Also importantly, I'm entering a specific number of cores, RAM, giving it a name, and clicking submit. So when the task is successfully submitted, you're going to see your job submitted information. You will know the specific job ID, but just don't care about this for a moment. It's mostly useful for debugging or getting into contact with us and getting some help. So error files is going to be stored in the folder task error, and the log file is going to be stored in the task output folder, so you can always go and check if something went wrong. But most importantly, you can always verify that something went well or not very well in the task option. So here I'm just switching to tasks, and what I'm seeing here that in the running I'm having the task I just submitted, and if I go to this part I will see the command that I've used, and in case I would have any troubles, I would see also the errors. Just as a reminder, you know when you submit it, when the job is started. Once it's completed, you will see also the time and date of the completion and the type of resources you used. While my task is actually being submitted, and because because each time I submit a task, a new node in the cloud is opening up. So it usually takes about a minute to launch a new node. What I want to demonstrate you is the ability of submitting multiple genome assemblies at once. So for example, here I'm actually having a small prepared script. So what I want to do it's a typical bash script, and here for different kmer sizes, I just would like to submit all my assemblies. So each time I'm actually calling the IDNA submit py, naming the task with different kmer as a suffix over here, and the input data, just as it is. So now, if I want to submit a bash script with the InsideDNA submit Python script inside, I just need to call bash here. So don't submit assembly RESH as another job, just call bash, and if you type, you will see that as you go, things get submitted. So right now you will have 3 more tasks running. So if I go to tasks, I again need to wait a little bit of time, so until those jobs will appear. But yeah, essentially you're going to have all those jobs. Just to demonstrate once more with the editor how this thing looks like with some coloration. So you see here I'm just using normal bash scripting. So right now I have all these 3 tasks already appearing, and now they are running. And now we will have to wait just a little bit to get the result done. Once the result is done, so just I'm quitting from my editor. So because I was actually storing all the results in the output folder, they will appear over here. But yeah, in principle, they are on my running line, and in a couple of minutes, I think, they're going to be done and transferred into the resulting folder. So this is it, and I hope that you will find this feature useful in your work. Remember, you are not limited anymore by the number of nodes on the cluster or the power of your server. Just like on a normal machine, you can submit as many tasks as you need to the cloud and get your analysis done quickly. So thanks a lot again, and if you have any questions, always contact us.